prezentację poprowadzi Lello. Jest to przedstawiciel marki Wisycom, zajmującej się transmisją bezprzewodową dźwięku. Leslie jest wieloletnim supportowcem i technikiem w firmie Wisycom z wieloletnim doświadczeniem, z naprawdę dużą wiedzą. Warto go posłuchać, warto też spotkać się z nim po dzisiejszej prezentacji. Jeszcze raz Lello. Leslie, floor is yours, please.
Hello, everyone. Cool. So, I work for Wisycom. Do I need the switch for the? Maybe. Sorry. Okay, I work for Wisycom, which is an Italian company involved into wireless microphone and RF distribution in general. The company is located in the northeast of Italy and close to Venice. It used to be called Pastega back in the 1780s and 90s, and was a company specialized in high power intercom system and was mainly focused on big sport events where at that time, the RF distribution, actually the RF transmission was made with these huge 8 watts, 20 watts amplifiers going, covering kilometers, where now the philosophy has slightly changed, but we'll see this later. Okay, so what's going on in the next years, or next year actually, and in the future in the RF environment? So this is a key question that everybody normally ask me when I'm at exhibitions, when I go to do installations, because of course it's a key argument, and everybody's kind of worried about this, especially people who need to purchase new devices. What surely is going to happen is that the 700 megahertz bandwidth will be lost for us, because it has been sold in the major countries, and then also the minor will happen soon to mobile phones, basically to the 5G and on. So this actually left us with a decreasing amount of space available for transmission, for reception, for wireless microphones, basically. So there are different ways to face this problem and to try to solve it. One is, of course, to optimizing the usage of the small amount of bandwidth that we have left. Talking about this, Wisycom has made a step in advance, technologically wise, with this patent, which is called linear, as you see on the top. Basically, linear technology is the answer Wisycom gave to all the people that were saying, okay, we just have this small amount of space, like 20 megahertz, or just few TV channels, few blocks, and how can we better use this small amount of space? And linear was, as said, our answer. Linear technology basically is what we have done. We decided not to decrease massively the power of the transmission, like other companies have decided to do, let's working with 1 or 2 milliwatts, because that, of course, would have decreased the intermodulation issues, also let's say how can we call it, the interference, but also, of course, the range, and that's something that we really didn't want to face. Wisycom has always been known to be a company with a big RF knowledge, and devices with our RF really robust. So the idea of finding this or accepting this kind of situation, or accepting the fact that we would have been not as good as we were in the past, that wasn't the solution for us. So it took us a couple of years basically to design this technology, but we ended with this function. And what we did actually is we introduce a second stage of amplification inside the transmitter on the body pack, but also the handle mic or the plug-on. And this second stage of amplification work as a sort of anti-phase amplifier for the intermodulation products, or for the interferences. What happens is that I will have the main carrier passing through, but the intermodulation products cut by 30 dB. This is maybe sounds a bit difficult to understand, especially if somebody is not that familiar with RF or with the intermodulation problems, but it's actually very simple. And on the concrete side, what you obtain is the fact that I can put my carriers, as you see on the top pictures, I can put my carriers equally spaced distance. So I can have, if I'm working in regular wideband, where normally it's 400 kilohertz, and the normal way to do this is I put one microphone on my frequency, then 400 kilohertz away from the second, and then the third already has to jump far away because I have to consider all the intermodulation issues that can be created by the two. In this case, I can put one every 400 kilohertz without considering any issue, any problem related to intermodulation. Together with this, we also introduced a different way of modulating the signal, which is a narrowband modulation, which allow us to work even closer. So basically, we can work at 200 kilohertz away, one carrier to the other. So this entire thing is just to explain that we need solutions to improve and to face actually with the problems that will come. And this kind of solution is something that we have been working with a lot. Last year we have done the US Open in New York, and I don't know if any one of you has ever made a RF scan, probably not in New York in center, but you will watch it and you will start crying because there are no available spaces, there is no room to transmit, and maybe you have to place 20 frequencies and you start say, okay, where do I start? When they asked us to do the US Open, they said, okay, we don't want to work in a regular UHF band. We want to work in a different place because there is no more room there. So what we did is we designed and we tuned some devices on an open spot, which is the 914 and 60 megahertz band, which is available only in US and Canada, which is only 20 megahertz, but together this amount of space and working with linear function and in narrow band was more than enough for us to do the entire show by using only 20 megahertz. And we're talking about the US Open, which is of course one of the main sport events on the US. So a lot of clicks. Okay, we have talked about the linear function, and I would like also to introduce you a little bit to our range of products. I picked 3 specifically because besides being probably my favorite ones, they're also the one that I find most intriguing and more specific and really difficult to make a comparison with something else you find on the market. So really unique units. I would like to start with MTK 952, which is our IM dual channel transmitter. This is a high power transmitter and goes from 10 milliwatts up to 2 watts of power. So the coverage, if you go straight with 2 watts on antenna, you can cover up to probably 4 kilometers easily, 4 or 5. But the point is not, of course, going every time with 2 watts on antenna, otherwise your colleagues will kill you and probably also the police will come. And, but it's the idea of combining a lot of carriers into a combiner without having any trouble in losing signal. So the idea is, okay, I've got 16 channels. I know that my loss between the cable and the combiner might be 13 dB or 15 dB. I don't want to reach the antenna with 2 or 3 milliwatts. I want to keep my 50 milliwatts. And having a board that mounted at 2 watts RF output there is really helpful from this point of view because it keeps on supplying power. And this unit works really well together with a combiner we do, which is called the CSI 16T. And it's what we call an intelligent combiner. So basically, it's able to communicate through the coax cable with the transmitter and say, look, I'm losing this amount of power due to the combination. Give me more power if you want me to reach the 50 or 100 milliwatts on the antenna after the combination. So yeah, so this is one of the unique characteristics of this transmitter, one of the reasons I really like it. The other is that it combines analog and digital technologies, which is let's say the path that we decided to follow as Wisycom. We on purpose decided not to develop yet a digital system. We have everything ready to do it if we want, but we decided to took the best out of the two technologies. So this, well, first of all, for the IM system, of course, delay was a key thing, and with digital system, delay can create a lot of troubles. The other thing is that MTK 952 is working wideband, so it works from 470 to 800 megahertz. So basically, it covers the entire UHF with one single unit. And the DSP that is mounted inside the device actually allowed to have a multi-compounding system, which makes this unit really effective and very easy to integrate with the already existing system, because you can use it, for example, with a Shure receiver or with Sennheiser receiver. So basically what you got is a highly performance transmitter with high power, really robust in terms of RF, which can be used with whatever receiver you got. Of course, we have our own receiver, IM, which is called MPR50, and is a true diversity receiver. So it mounts to RF boards inside this small chassis, which is really impressive, and RF-wise is highly, highly sensitive and allow you to cover big areas even if you're working only with 10 milliwatts or 50 milliwatts. And so this is one of the devices. Of course, it's remote control. So everything basically now is moving into software, and we barely touch the hardware anymore, especially in studios application. When I go to do installations, we go into the machine room, we mount all the racks, we stack them there, and then we don't touch them basically anymore. So we do everything directly from the software manager. So this is the MTK. I said it's dual channel, and it's of course stereo. This is a typical application. It was a studio I went to do an installation in, and it was in Athens. It's an Alpha TV studio. And here is an example of where the 2 watts power came and helped me massively, because they were running really long cables, and they had to reach many different antennas, and they wanted to use this philosophy, which is becoming more and more popular now, which is everybody has to go anywhere with everything. So basically, whatever is the body pack, the receiver I have to, or the transmitter, I want to be able to move from, in this case, from Studio 1 to Studio 4 without any kind of dropout. So one single control room centered, and all the signals spreading through the studios. This wouldn't been possible without having such a transmitter or such a RF power on the transmitter, because otherwise the loss of the cables would have been a nightmare. We would have reached probably the studios with 1 or 2 milliwatts, which wasn't an option. And in this case, the one you see in the center is the so-called intelligent combiner, the CSI 16T, which is the one communicating with the transmitter and saying, okay, I'm losing this amount of power, give me more if you want me to work properly. Good. This is the second device I wanted to present. This is probably I would say my favorite when I go to do installations, because it's something that changed my way of working with RF massively. Basically, this is a matrix. So it has 8 diversity outputs and 8 diversity inputs with 4 outputs. And you can consider this one as a sort of mixer, like the mixer you got on for the audio engineers. So basically, this gives you control of 8 different pairs of antennas, or so-called zones, and give you the possibility not only to turn them on and off and to power the boosters, but also to adjust the gain, for example, and meter the RF levels. This is very important in applications like in studios or big theaters, where you got different zones. You got the main stage, you got the backstage, and a changing room where you want you want your signal to be strong. These metrics allow you to basically to switch on and off the areas you're working with. So you got the sum of signal of RF energy coming into your receivers, but you're also capable of say, okay, let's cut the outside zone because we finished shooting there, we finished with the live there, and I don't want any kind of interference coming in. And when I press the button, not only turn off the booster, but it's like cutting the cable. I completely interrupt the reception coming from that specific area. This has become a must in most of the studios around the world now, because it's a unique product, so you don't find any other matrix working the way this one is working specifically. And now, even if they're using, for example, different microphone solutions, but the matrix is what they always call us to have. There is one other thing which is very important, of course, is the fact that you can remote control the matrix. So it's the typical hardware that you put on top of the rack, and you forgot about that. You just control it directly by the software, by the manager. And the other thing which I found personally really nice is the fact that you can remote control the antennas. We do produce, as Wisycom, some antennas called LFA, which integrates a filter of 40 megahertz and a plus 27 dB gain, which is very useful as well as dangerous if you don't know you're gaining that much. And what you can do through the matrix is connect the antenna here, place them all over the studio, whatever place you have to, you're doing your installation, and then sit in front of the computer and lifting up gain or padding, because it goes actually, the antenna goes from -12 to +27. So you can also decide to attenuate the signal if you are running the risk of having saturation. And also you can filter them. You can filter directly the antenna, and everything, all this is done directly by the computer. So you don't have any more to put the antenna, then check the signals, then climb up and change 1 or 2 gain, and then go down, and then you discover that there was another mistake, so you have to go back there. So everything is just done directly by the software. And in the installation I showed you before, the one in Athens, this thing kind of saved my life, because the studio was still under work in progress, so there were cables everywhere, there were holes on the floor, and it was really difficult to move from one studio to another. So once we placed the antenna, we just went into the control room and we set the gain from there, and that was awesome. Okay, so this is the matrix. The other thing I really appreciate is the fact that it gives you, it has 2 RF bars, which shows you the sum of the RF power that is going through the matrix to your receivers. So I can monitor anytime what the level are. And if I turn on one area at each, I have a perfect idea, a perfect picture of how my RF environment is behaving, and if there is any kind of dropout, any kind of problem or whatever. So this to me is great, but because back in the days it wasn't that easy to work with RF like it is now, of course. And especially RF was this thing where you were plugging the cables to the receiver, to the antennas, hoping that everything was fine. If this level were low, you were just, gaining a little bit on the booster, and that's it. But you actually didn't have real control of what was going on. Where now actually you have different stages directly from the computer. You can control everything's going on. We have to say also that probably 15, 20 years ago, the problem wasn't really there, because there was enough space for everyone to transmit. The noise floor wasn't that high. 3G, 4G were, far away to become part of our lives. So of course we had to adapt. And this, I found this solution as one of the most versatile that are available at the moment to make you feel a bit more relaxed. I mean, so relaxed that now when I have to go with more than 4 antennas, I always bring a matrix with me, which sounds like an exaggeration, but I got probably spoiled. Okay, this is a studio I've been designing in Madrid, where they wanted to have basically 6 studios and 1 single control room. And they wanted everyone the same thing as before. Everyone had to go everywhere with the mic. So the idea was to have a control room where all the gears were, and have 1 computer in each studio which can control the devices remotely. What I've done was a cascade of matrix. So you see the squares on top are the 6 studios, and I divided them into macro group of 3. And they are going into the matrix, and from the matrix going into the splitter, which is the SPL 2208. This allowed me to do 2 things. First of all, switching off the single studios by switching off the areas from the matrix. So if I don't want to work in Studio 4 and Studio 2, I just simply had to go actually from the computer and turn it off. But also I can decide to quickly switch off an entire area of 3 studios by going into the splitter, which has the kind of similar function of the matrix, and I could turn off, let's say, studio 4, 5, and 6 by pressing 2 buttons. So this is what I'm saying, back to the idea, okay, there is a big area, a lot of microphones, because here we're talking about 120 channels, and give me solutions that make me feel more relaxed, especially if I don't have the gears in front of me, but I have just the software. Put me in the condition of, of working or having an easy workflow where I can have control of everything going on, antennas, RF on the matrix, a splitter, and the signal going to the receiver, basically. This is another example that we have done in a big stadium for a big concert. We have been working with big artists so far, especially with the IM system. We've done with Stevie Wonder, with Madonna, with Justin Bieber, I guess. So the system is becoming more and more popular for the reason I explained before. But also, which was kind of unexpected from the live world and from theaters, they were not just interested in microphone and in IM, which makes sense, but also in all the distribution part, because now, you probably know it better than I do, you start having bigger venues, bigger LED walls, systems which are more and more complicated. So also RF is becoming an issue. And of course, as we said, noise floor is always higher. So we need to have the tools to make our job a bit easier. And in this case, they had two big areas. So there was the main stage on the right and the entrance where they were doing part of the show and interviews and broadcasting part on the left. And there was one central OB van outside that was basically controlling the 2 areas. And he could remotely switch off all the antennas that he wanted based on if this antenna were receiving any kind of interference or not. This was assuring that the show would have no problem at all from the RF point of view. Okay, we talked about the matrix, and this is the last device I would like to talk about. As we are here to talk a little bit about new technologies and new ways of doing things. This is the MFL, basically is an RF over fiber system. This device allows us to carry our RF signal from one point A to point B without basically considering any kind of problem related to the cable loss. This is, of course, a big advantage. If you think that a regular or a good RF cable, a coax cable, has a loss of maybe, let's say, 1 or 2 dB per each 10 meters, a good one, the fiber link has 0.3 dB per kilometer. So there is no gain. The idea of if I have to spread signal in different places or far away, fiber is nowadays the only solution. As I said at the beginning, back in the days we used to have big amplifiers to send signals all over the places. The RF spectrum was much better, there was no noise, and on and on. Now the philosophy has changed, and for example, we work a lot with Formula 1 and MotoGP with these kind of solutions. And the idea is we don't want to transmit anymore directly from the OB vans with these high power antennas, but we want to be directly on the paddocks or on the pit lane with antennas, regular log periodic antennas. So the only way to do this was to carry the signal by using a RF over fiber system. This is a configurable system. It has 4 modules. You see the 4 colors, orange, yellow, green, and blue. And they can be either transmitting lasers or photodiodes or receiving modules. So basically I can decide if I want to use this in transmission for my IM or IFB or reception for my receiving antenna, or in both directions. So I can work bidirectionally. This has changed everything I knew, at least, about distributing RF signals, especially when I have to go and do an installation. I've been doing the New York, the ball drop in Times Square, And basically, I think I have a slide of that. Yeah, perfect. This is Times Square in New York for New Year's Eve. And we had 5 different stages outside and one single OB van where all the signal had to be collected and then resended to the TV channel, which was CBS or ABC, I guess. And back in the days, they had to run actually long coax cable to put a lot of booster in between because they were running maybe 200 or 300 meters or 400 meters of cables, very heavy cables, very expensive cables. Now the only thing that I asked when they call me, okay, what do you need for the show, is, okay, are you taking fibers for the video? Yes. Okay, just put some more fiber, and I will use those for the RF, and that's it. So basically, no loss, perfect coverage, antenna straight to the point, and I was sending back and forth all my signal only using the very basic CAPC fiber patches, and these we had like 4 days of rehearsal, and we didn't know what to try anymore because everything was done basically in 1 day and a half. And this has been a real game changer for us and for all the broadcaster world, I would say. Even because it was born for a system, it was born to be a system for the outside application, so going point to point, making straight 7 kilometers of fiber. But then suddenly all the studios realized that if they had to redo or redesign their own RF setup, there was no reason to make holes in the walls to put new coax cables, better coax cable. They could simply use the fiber system that they already had for data or for anything else. So basically, it's so easy to integrate this system in pre-existing situation that everybody now is saying, okay, the advantages are so more than the disadvantages that it's becoming almost a must, especially in the US. We've been doing so many studios like this, and it's been quite an easy job, I have to say. Because if there is one device that is almost plug and play in Wisycom, I would say that is the RF over fiber. Good. So this is how we did the whole show. We have different receivers and transmitter, and of course remotely controlled antenna. Everything was controlled from the OB van directly, and we had a matrix. And here is also one of the application, for example, of the matrix, which is quite useful. The show was starting at 6 p.m. from the first stage and was moving down to Times Square every, 1 hour. They were changing stage with a new guest, a new presenter, and the wave of people was moving down up to the last stage, which is the one just underneath the big building where the ball is dropped. And basically what we were doing was just following. As soon as they were finishing in one stage and going to the other, we were using the matrix, just switching off the antennas, and we were sure we had no problems coming from that area. Actually, what we were doing was keeping on only the antennas from the stage we were shooting. And that was a great thing because we didn't have to care basically about anything else. And okay. Well, this system, I haven't mentioned this, but I thought it was obvious, but maybe it's not. Both the matrix and also the RF over fiber system can work with basically whatever system that is working in the UHF. So you don't need to have a Wisycom transmitter or receiver. There are some things you have to be careful about, especially because the fiber cannot carry RF power, so you need to re-amplify the signal on the remote area. That's why we have devices like the small booster you see on the right, the PAW, which is a booster for amplification that is amplified by a regular 12 volts bias, the same you use for reception, but it provides up to 200 milliwatts of power. So you have to be careful about that because the fiber saturates quite easily. But beside that, you can use it with whatever system, which is a Sennheiser or Shure or whatever, audio limited. We basically don't care. It's like an ignorant system. They just carry RF from one side to another and give you the possibility of switching on and off antenna, talking about the matrix. Okay. So we go to, this is like a range also of application. So in the live world and in the theaters, the fiber is still something that is, they are starting now, but of course it will take time, also for a budget point of view, and yeah, and also for the RF knowledge that maybe this technician might have, that sometimes there are more audio guys that are forced to be also RF people. But there are different solutions, and we're actually covering all this kind of application. Another kind of solution is for this golf tour that I've been drawing, and they only had one obi van. And if there is one thing that in the golf they hate, is to see cables and antennas. Golf they hate to see; they don't want to see anything. I don't know exactly why. So we really had to hide everything into trees and hide the cables under the ground and everything. But again, if I have to use like highly or low loss cables, of coax cables, and hide them and put them on the trees, it's pretty complicated. It's expensive, and you need a lot of manpower too. Where the fiber was so easy, you just have a small, like 500 meters of fiber is just something like that. You can easily put it on the ground, cover it. If people steps on it, you don't really care. And because of course you take shielded one, and you put on the trees. And there was one installation we have done in Paris for the 14th of July, which is the Bastille Day, or like the national day. There was this big parade, and we had all the fibers running through the trees because we wanted to have coverage for a few kilometers. And then when it was time to dismount, we dropped the fiber there, because it was more expensive in terms of time to take them down than to buy them new once we were back to the warehouse. So I know it's not nice to throw away stuff, but sometimes it's just to say that it saves time, it saves money, of course, and when you're tired. Hello? Okay, back on. So, where was I? Just another example. So this is just to show how versatile the whole thing about distributing RF is. And of course, as I said, you can work with either our transmitter, receiver, and all our microphone part, but as well as with other companies. Okay, this is another example. Here we're using transmitter and receiver. We have the IM transmitter, high power, and the receiver side. And what we do here in this case is we send out the signal from the transmitter, and we want to transmit into different locations. What happens often in these cases, you might have problem if you're transmitting, like let's say here and there, and when I'm moving from one location to the other, my receiver might have some problems, of course. With this system, we work in the so-called ISO frequency. So it's not two transmitter amplifying the same signal, but it's basically the same signal being amplified twice. It's like if it was the same system split it into different locations. Sounds weird, but actually makes a big difference when it's time of doing coverages. Yeah, I've been going a bit fast. I know it has been a long day, especially for you, so I didn't want to force you staying here listening nonsenses about RF and stuff. I hope this was clear. I just wanted to give a quick overview about the products, about the potential, and also on the side warn you, because the things are going from now on, they're going worse and worse. Talking about RF environment. So we need to be prepared and to think in advance what the solutions can be, which can be either a microphone like the linear, let's say linear, or whatever, any other technology that you might look for. So both on the microphone side, on the IM side, but also on the RF distribution side, because a well-made antenna positioning system and a very solid RF devices that can make a big difference in your daily job, especially with I said RF that sometimes can be a big pain in the neck. Done. I don't know if there is any question, something you're curious about, or we can. I'll be around here eventually if you want. Seems not great. Yeah? Yeah, I was expecting this question. Yeah, we're moving into something slightly different. We're also covering all the location, sound, and cinema market, and just make an introduction for people who doesn't know. And we have also body pack receivers and body pack transmitters and bag receiver. And we are about to present, officially will be presented at NAB in April. We have a new camera slot-in receiver, which is going to be 4 channels, true diversity. So it has been a bloodbath to design it, because to be able to put eight receiving boards in that amount of space has been pretty complicated, but fortunately our engineers are brave guys, and they kept on doing that. So yeah, it's officially going to be presented very soon. I would say the first production will be probably in April. That's has Bluetooth and USB-C and a few other options. We'll also have an app to control it. Because yeah, otherwise, setting up 4 channels manually with a small display would be highly complicated. Okay, any other question? No. Well, okay, thank you very much for your patience. I know it's been tough, but also very interesting. And thanks to all the organizers. Thank you guys for having me here. And hopefully we'll see us next year. Cool. Ciao.